Alright, so I'm back. As you can see, where we left off, I was going to shut down the burners and everything so that I could replace the thermal pile to let everything cool down. Still hooked up to the wires of the thermal pile. The red one is obviously positive, goes to TP, and the white one is goes to the TP TH terminals. So as you can see, my multimeter shows that I have 0 volts, and finally getting somewhere now that I've got, like I said before, my Fluke multimeter. That is my professional multimeter that I used to use in my business. It would have been handy if the Klein tools would have put this in their information that it didn't read millivolts, or I should have been smart enough to figure it out. But anyway, I wasted some time trying to figure that all out and decided to try my Fluke multimeter out, and quickly found out that my voltages were not where they should have been. The Klein multimeter doesn't start reading until it gets to as you can see, it says 0.0, or my Fluke says 0.000. Well, I didn't pay any attention to that. I thought this was just an infinite multimeter. I thought, just assumed that it was, and found out that it's not unless I'm doing something wrong. But anyway, unless it was reading 1 volt or more, it would show up as it wouldn't even read on this, which it wasn't doing, because once I did hook this up, I indeed did have millivolt readings of around 300 with the pilot light on and heating the thermo generator or thermo pile, which was creating that voltage to supply the system to be an electric free system, or electricity, AC free. It's still a DC system. And as you can see, I have got the pilot light off and everything right now. I wanted to show you, now that I've got a flashlight in here, what I was talking about earlier on this wire right here. Yeah, I've never seen one before until I worked on this one. I've changed out a lot of thermocouplers, but they do show this, being able to buy this whole unit, and they can buy the thermal pile separate, but they mainly sell this as a unit because this piece here on the thermocoupler looks to me like it's got a resistor or a diode in it. It's kind of a little bump on the side there. It looks like a diode, but anyway, it is soldered to the side of the burner, the pilot burner. That's probably why they sell the whole unit, because most people aren't gonna have the ability to solder that on. And this is, of course, your igniter that ignites your pilot during startup. And to change the thermal pile, you actually do have to spread this, this little bracket out back here, so that you can get the thermal, and of course squeeze it back down when you're done. But that would allow you to be able to pull your thermal pile out the back. Now, my thermopile here, you can see I've turned it. It was, you can see that was facing the bottom. That's why it's burnt like that. Now if I turn it over, I put the newer portion down towards the bottom, thinking, well, maybe I could generate more voltage with a fresh source with no carbon or anything on it, which I could have cleaned that other off, but that'd be easier just to switch it over. Well, it's still producing some millivolts, but like we talked about earlier, not enough. So anyway, that is, I will take that thermopile out of there, and we will unhook all our equipment down here, and then all I have to do is take these two screws loose, pull these wires out, and I'll tape my new thermopile end to those wires, and I'll just pull the whole thing through and feed it back up there to make it a lot easier. As there, you can see there's very little room to work in there, and that's why I took this valve off, so I could reach the back side of the regulator here, and I could reach where I talked about earlier, that blue wire, which I don't know if I can get some light in there where you can see. Kind of hard to get in this confined spot and get you a decent video, but you can see that little blue wire down below, and it kind of runs in a channel all the way to the back of the valve, and there's probably about a plug about 1 inch across that has a little knob on the end of it that wire solders to, and that obviously is connected to the thermocoupler here. Comes in behind, hooks into a little plastic deal back here. You can barely see that little white plastic deal. That's actually got a blade inside of it, and the plastic insulates it from the valve, and so that when you screw this thermocoupler in, it just bottoms out on the blade on the end of that blue wire, and that goes around to the back of the valve here, and it's actually directly behind your pilot valve, and it basically is just a big magnet that when it gets power and you're pushing in and holding this to light the pilot, when it reaches enough temperature, the high enough temperature to energize that magnet back there that's inside the valve via this the voltage coming through here from the thermocoupler up at the top transmits through the blue wire back to the magnet in the back. And that's what, once you let off this, after holding it on 20-30 seconds or so, usually if it isn't holding by then, your thermocoupler is probably bad, which in this instance, like I said before, it's kind of comes in all one piece. You can buy the new thermocoupler and the thermopile all together. A little more pricey than just buying the thermopile when that's all you need, so that's why I did what I did. And besides that, I was able to get it for $13 on the clearance rack at Ace Hardware. So anyway, that's the process that takes. I'm going to go ahead and pause the video here and get the wires off and thread that new generator in, and then we will check her out and see if I found the problem. Alright, so here we're back. I got my new thermopile threaded in by taping it to the old one and pulling it through like I said I was going to do. So it's all back in here, and it's not the exact original, but it's a 750 millivolt, 600 to 750 millivolt thermopile, which they call for a 750. And I just squeezed the little clamp back together to hold it in place, and got it wired back up, and we are hooked to the TPTH with the black multimeter lead, and we are hooked to TP with the red side, which is a positive coming from the thermopile, and the TPTH is a negative coming from the thermopile. And again, that creates a millivoltage to allow this to work without any kind of electricity. It self-generates through the thermopile or thermogenerator. Got my multimeter turned back on here. Right now we don't have the pilot light lit, so we're at 0 voltage right now, and I got the switch turned to off. Let's actually bullet it back on while we were away, because I didn't have to get back in there to test the pilot safety valve. I don't know the proper word for it, but one the blue wire goes to. And I'm going to go ahead and attempt to turn my camera here. Sorry. Well, maybe. So that I can light this pilot light and stay on the air here. As you can see, there's a maybe little white arrow there. Get all the wires out of the way. Right now I've got it turned off, and I'm going to push in on it and turn it counterclockwise till it's on pilot. And I will push in on the valve, and ignite pilot light while I'm holding in on the valve still. And I usually try to release it slowly, just in case it will try to go out, which there I left off over it all the way, and the pilot light stayed lit. Now, as that pilot light is warming up the thermopile, get the light out of the way so you can see it. You can see the voltage starting to go up to the regulating valve, and voltage is continuing to rise, and hopefully we'll get past 190 volts that we were at earlier. Well, we were actually at 300 before we turned the valve on. If it doesn't, we'll get back to square one. Takes a little while for that to heat up. Remember, it has to have about right here, about the minimum voltage for it to stay on once you fire up the stove. While we're waiting for that to heat up, again, this is I don't know if you can see it very well, but the sit valve symbol is right there. That is the system that Desa used on here, that is what you're looking at, this sit regulating valve right there. And as I said before, I had replaced this with I don't know if you can see it there where it shows where I put this valve has been converted using sit LPG, which is propane modulating conversion kit. And basically, from my understanding, that is converting it from that old style valve, stepper motor valve, which was this style, and it comes a complete assembly with built-in seal and all that, and there's a little solenoid down inside there, that as that stepper motor opens up, allows more gas to come through the system, and that's how it modulates the flame height, is by how far that valve is open. As I showed you earlier, it's controlled by the remote control, and this is the installation kit that came with it. And this is basically this Nova valve is, as you can see, a millivolt valve, set valve. You can see here, set, and so it does fit my valve. It was designed to fit this particular valve, and so now we're up to about 275 millivolts, and I'm not 100% sure that that's going to be enough. And if that's the case, it's because the thermal pile is not getting hot enough to create voltage. The hotter it gets, the more voltage it creates, and it may need to have may need to be adjusted to where the flame is a little closer to the thermal pile, because it does have a pretty good sized pilot there. So of course I don't like to have any bigger pilot than I need, because it's just a waste of gas. And like I said before, there's a couple little holes down in here on this pipe, but I said earlier that I think that helps keep the thermal pile hot. Well, it might, but it also is, actually the holes might be there, I can't hardly see it, but anyway, that propane will come out those holes, and that will ignite this system and go all the way around. And where the slotted holes are is where the fire comes out. And there's a very small flame comes out through here. All this is to light the different areas of the pipe underneath the logs, and where they don't want flame coming up, they have very small holes, and where they want the flame coming out, they have the slotted holes. And it keeps the natural look of the flame, and it keeps the direct flame off of your fake logs. So anyway, we are up to 280 millivolts. So I'm going to try to fire this baby up. First off, I'm just going to turn it on manually, and as you can see, my voltage just dropped to 177. So as I said before, yeah, my thermopile might not have been bad. It just may not have been getting enough heat on the thermopile, because right now we're still not getting enough millivolts to start the flame. And so we're going to go back to our old trick and ensure that I pre-tested this thermopile, and it indeed does put out 750 millivolts, and when it has heat applied to it. So I'm going to try to apply a little extra heat to it, and our voltage is going up, as you can see. 350 millivolts. And 386 millivolts. It's still not kicking on. So maybe my bargain thermopile wasn't worth the money. Because, well, it might help if I turn the valve on. I forgot to turn it from pilot to on, so I'm going to shut the switch back off. And I'm going to turn it to on and see if that doesn't help. Well, right now we're at 500 millivolts now that it is dropping since I took the flame off of it. So I'm going to go ahead and let that cool back down too, since I added the extra heat to it. And I apologize. I am by no means a professional, just trying to help somebody else, hopefully, that has been in a jam like me. Can't afford to have somebody come work on this thing, so myself, learning from multiple videos online, and appreciate the help I've gotten from those. Apologize for any shakiness in my hands and in my voice, and for not being able to remember what things are called in proper usage of terms, but I have suffered from 2 open heart surgeries and 2 heart ablation surgeries, a stroke, and multiple other surgeries, and so I am a little shaky, and my brain doesn't always work quite right, so not to mention my heart doesn't beat right, so that's my excuse for such a crappy video, and for not being able to remember to turn valves on. So now we're down about 300 millivolts again, which is where we were with the old thermal generator. So this is beginning to worry me a little bit, because I was hoping I'd be producing a little more voltage for this system with the new thermopile. So now that it seems like it's kind of stabilized here, I'm going to go ahead and manually kick it on. And unfortunately, as you can see, my voltage has dropped, which it will, because we are now trying to energize the set valve, and it's not dropping as much as the old one was. I believe we were getting down to about 150 milliamps with the old thermopile. I'm not quite understanding with the extra voltage here why the system's not kicking on. So, double check, make sure I am in on position. Gas valve is on. Need to make sure that wires from my thermostat are hooked up, and they are. So we've dropped down to 170 millivolts now. So I'm going to yet again try to heat the thermopile back up. See if that's where our problem lies still. This would have probably worked earlier had I had the gas turned on. So as I'm heating that up, you see the voltage going back up. With the old thermopile in there, I had to get it up about 350 before this thing kicked on. Well, it just kicked on, and we are about 300 millivolts. So, as you can see, we're about 100 millivolts shy of being able to turn this thing on automatically by itself without being assisted. So we're going to have to be able to get more heat on that thermopile to energize the coil on the regulator. So never easy. Well, it's got to be the hard way. So as you can see, the voltage has dropped now that I've let off of my torch off of the thermopile. It's dropping back down into that where it was before, around the 200 millivolt range with the gas valve turned on. Which it's normal for it to drop with the valve on, as I said before, because of the draw on the system. But the reason it's working now with the lower millivolts is because it's not having to manually move the valve. It's just maintaining it in the position that it's in. So that's why the flame's staying lit, even though we're not anywhere close to the 300 millivolts it took to turn it on. So next step, try to get more heat on the thermopile. Okay, I made a little adjustment to the angle of, well, you can see I'm at 424 millivolts now that it's leveled out. What I did is I adjusted the thermopile so that it was touching the flame a little better. Yeah, I'll show you exactly what I did. Right in there, I can find it on the camera here. You can see I also cleaned through that little hole there. I also cleaned the little bit of dust and stuff that was around the pilot itself. That's the draw hole that it draws oxygen through for your pilot. And anyway, right on the back side of that is the orifice for the pilot. And right above it, you can see the back side of the new thermopile that I put in. And there's the bracket that it squeezes into or squeezes down on. I can get a decent shot of it. And that was actually bent down a little bit. Now it's more level. And the way that I did that, I can get some decent light in here on it. And another hand, I used a screwdriver and simply went in between the back of that clamp and gave it a little twist. And actually just bent that back up to where it looked like it originally was. How it would have got bent down, I'm not really sure. Maybe I did it when I was spreading it out. I probably did. And anyway, the thermopile is just a little bit more in the flame. As you can see, it's kind of bending around, the flame's kind of bending around the thermopile. As a result, we're getting a lot better static or voltage here, and